Hello, welcome to another video. In this video, I'm going to go through a JavaScript library for adding diagramming features to your web applications. So previously, we covered a fantastic library called JSPlum that serves a very similar purpose. This time around, we're going to go through a library called X6. So one thing to note about X6 is that the English documentation for X6 is very limited, but there is a tutorial that has a lot of sample code, and even though most of it has not been translated to English, it's still quite readable because it has tons and tons of sample codes. And if you look at a gallery here, there are also lots and lots of examples for you to follow that showcase each of the features of the library. And this code here, the code in these demos is actually quite easy to follow as well. So don't be turned off by this library just because most of the documentation is not in English. It's still quite easy to get started with. Okay, so before we get started, let's look at what we're going to build today. Here is the final state of what we're aiming to accomplish today. On the right-hand side here, this is the graph. And on the left-hand side, this is the stencil area. So graphs in X6 consists of nodes and edges. So let's go and create some nodes and edges. So let's create a MySQL node. Let's create a filter node. And let's create a MongoDB node. Okay. So now we have 3 nodes in the graph. So now let's create a connection between these nodes, right? So let's connect MySQL to filter and filter to MongoDB. So this line here between the node, this line is called an edge. So nodes here, in this particular example, the node is a rounded rectangle, but nodes can have different shapes. For example, you could have a node that looks like a circle, or you can even use more advanced nodes that render HTML or display an image. So let's get started on the code to implement the demo that you saw earlier. So what I have here is a very bare bones TypeScript project. And if you look at the package.json, you'll see that I've included X6 as well as jQuery. And I have created a very simple HTML file using Bootstrap. And on the left-hand side, I've created a div for the stencil. And on the right-hand side, I've created a div for the graph. So this library is very, very feature rich. So let's start with the very basics and let's create some nodes and an edge. So first off, let's initialize the graph. And now let's add a rectangle node. And let's also add a circle. And now let's connect the rectangle to the circle using an edge. So of course we can drag the node wherever we want and the edge remains intact. So in this example, I showed you how to create nodes and edges using the add node and the add edge methods, but there's an alternative way to add nodes and edges, which I much prefer, and that's using the constructors of the respective shapes. So let's change our code here. Let's refactor our code to use the constructors rather than the add node and add edge functions. So let's add the rectangle first. And now let's add the circle. And let's add the edge as well. Let's add some styling to the graph. First, let's change the look of the rectangle. And let's do the same for the circle. We can also style the edge, and let's first try to change the source and target marker. So this, we can change the icon at the end here, as well as the icon at the beginning here. So let's play around with that first. So let's make the target marker a diamond, for example. So diamond, yeah. And let's make the source marker a circle. And let's change the color of that line. So let's make the color purple. We can also change the router, which determines how the path is made between the two nodes. So by default, it finds the most direct line, but you can also use some other alternatives. So let's look at some examples. So this is the ORth router. This is the ER router. And this is the Metro router. You can also change the style of the line between these two nodes. For example, if you want a smooth line rather than a straight line like this, you can use the connector smooth. You can also change it to rounded, for example, rounded. So it's quite tedious to have to style the node each time we create an instance of it. So what if we could instead define the styling for a class of nodes once, and then reuse that styling each time we create an instance of that type of node. So now what I want you to do is I want you to imagine that we're creating a diagramming tool for a workflow engine. We're going to want to have shapes that represent input, process, and output. So what we're going to do is we're going to create custom shape classes, custom node classes that are child classes of the built-in rectangle shape. So we'll create a subclass of rectangle to represent input, process, and output. And in each of these subclasses, we will give that type of node custom styling. Okay. So you'll see later that input will be styled so that the fill is blue and the stroke is a slightly darker blue. Okay, so let's start with the input custom node type. Let's start with that. And this is the class. And here is the custom styling that we're introducing for the input subclass. And let us now register the node. And after registering the node, we can create an instance of that node type. Okay, so let's create an instance of that node type and let's add it to the graph. Okay, so here we're creating the instance of the node class and we are adding it to the graph using the add node method. Okay, so similarly, let's add the other subclasses, the other custom node subclasses, which are process and output. Okay, so now I've added all three of the custom node types, one for input, one for process, and one for output. And I've created an instance of each and added it to the graph. So next, let's connect those three nodes together using edges. Okay, so next let's look at converting graphs to and from JSON. So the easiest way for me to demo this is from the JavaScript console. But in order to show it to you from the JavaScript console, I need to save the graph object in the window object. So it's easy for me to access it from the JavaScript console. So let me do that now. Okay, so now that I've done this, I've added the graph object to the window object. I should be able to access it from the JavaScript console. So in order to convert the state of the current graph, the state of the graph in its current state to JSON, we simply have to do graph.toJSON. Now remember that everything here, whether it's a node or an edge, is a cell. So that's why we see this array here, cells with 5 items, because we have 3 nodes and 2 edges. Now let's save this to a variable. So let's do x is equal to graph.toJSON. Okay, now let's change this graph a little bit, right? And because we've saved the previous state to a variable, we should be able to restore the graph to its previous state by using the graph.fromJSON function. Oftentimes, we want to attach some domain-specific attributes to each of these node instances. So the way we do that in X6 is to set the data attribute. So now when we export this graph to JSON, we should see those domain-specific attributes in the data property. Of course, what we really want to do is allow the user to create instances of these nodes on their own. So for that, we need to use a stencil. So the stencil will be this user interface widget that we'll have on the left-hand side here. And inside there will be multiple groups. And in each of those groups, there will be node types. And the user will be able to drag that node type to the graph on the right-hand side. So what I've done here is I've created a stencil and I've created 3 groups: input, process, and output. So now what we want to do is we want to add a few node types to input, a few node types to process, and a few node types to output. Okay, so we don't need these add node and add edge anymore because we're going to allow the user to create these by themselves. So let's just delete these. So now the user is able to drag and drop these node types on their own. Okay, but now the problem is that the user is not able to connect these nodes together. So for this, we need to use ports. Let's add ports to each of these node types. For the input node, we want the port to be on the right-hand side. For the output nodes, we want the port to be on the left-hand side. And for these process ports, the process nodes, we want one port on the left-hand side and one port on the right-hand side. To create a port, we need to create a port group and then define a port as part of that port group. So let's do that right now. So here I've defined a port group called output for the input node type, and I've also defined a port called output port that is in that group. So let's do the same for process and output. So for process, we have a port on both sides. And for output, we only have a port on the left-hand side. So you see how these two nodes are too close to each other, right? So let's just expand this stencil graph width so that there's enough space for both of them. Okay, so I skipped a step just now. I forgot to explain what this magnet does. What this magnet does is that it tells X6 whether you want the node to be the source of an edge or not. So for example, here, I've made this in the input node type. I've marked this particular port as magnet is equal to true. So because it's magnet equal to true, when I hover over it, I can initiate an edge from there, right? Okay. However, for the output node, I'm not able to initiate an edge from there because for output, I've set that port to magnet is equal to passive. Okay, so there are a few problems here. And the first problem is that we can have an edge that doesn't point to anything. So let me show an example. I created this, and then I create a node with an edge, and see it doesn't point to anything. So we can fix this easily by just setting a parameter in the graph. So now when we create an edge that doesn't point anywhere, it gets deleted. The other problem is that we can connect ports to nodes directly rather than to a port. So see, in this case, the port here is connected to this node rather than this port here. So to prevent that, what we can do is we can set allow node is equal to false. So now, when we create the edge, we're not able to connect here, but we're able to connect to the port. What we can do is we can actually set snap is equal to true. And what this will do is it will guide the mouse pointer towards the closest port. So let's show that example. So when I create, when I try to create an edge, as soon as it's close to a port, it automatically moves the head of that edge to the respective port. So we have one more problem, and that problem is that we can have connections that don't make sense. So for example, we can have two output ports that connect to each other, right? Or we can have an output port connect to the output port of another node type. So these types of connections should be invalid. It shouldn't be allowed by the system because it doesn't make sense. An output port should always connect to another input port. So for that, we can use this validate connection function to resolve, right? So what we want to do is we want the target port, right? When we're creating an edge, we always want the target port to be an input port. So we can write the code as follows, right? So when we refresh, we should not be able to create that connection anymore. Yeah, so we're not able to create that. But we're able to create the correct connection from an an output port to an input port. Okay. We can also style these ports. So for example, if you want to make the color of this port light gray, we can do that quite easily. So let's look at port, and you see here it says circle, right? So we can set this to fill is equal to light gray. Finally, we want to add support for adding and removing nodes and edges. So X6 makes this really easy because they have built-in node and edge tools. So first, let's create a button to remove nodes. So what we're going to do here is when the user hovers over a node, we're going to add a button in that node that allows them to delete that node from the graph. Okay, so now when we hover over the node, we can remove it by just clicking on the X button. So what we want to do is when we leave the node, we also want to remove the tool so that it doesn't, create that visual noise. So let's do that. So when we hover, we see it, but when we hover out, we don't see it. So similarly, let's create support for removing edges. So when I hover over the edge, it has this X button. So that X button allows me to remove it. Thanks for staying until the end. Let me know what your use cases are for X6, and then maybe I can do a follow-up video on this. Thanks so much for watching.